Dooby 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 doo. Dooby 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 doo. Dooby doo. Hey, we have sound. Do you like the intro music? Do it myself. Welcome to another session of Rust projecting. And this is the biggie. I've been learning Rust, for a month? Yeah, for just over a month. We've had, 4 sessions? 5, 6 sessions or so. And I'm comfortable enough now to do the big project, Game Dev Studio. So what are we doing today? We'll do a bit of setup, I think. Right. So we're going to try and set up a really big project. And I mean big. We're talking years. This is the project that should take you forever. In fact, if I'm right, it's one that never stops. It's the backbone, or eventually will become the backbone, of anything else you want to do. Now, in the last few streams I've been doing, we did do our first game. Now, it wasn't brilliant. Okay, it wasn't a brilliant game, but we did it. And we can use that a little bit as a template on how to start this. But there's other considerations. So, setup. What considerations do we have on the setup? Well, when I did the game development, or learning, I suppose, I couldn't really call it development, but we got some good code out of it. I found that when I put the files to GitHub, it was in 2 separate GitHubs. And I don't want that. I want everything in one place. So our setup is going to be different. A little bit different, if I can work it out. Yeah, I have to work everything out. Now, the rules for this, doing that game thing only took us, I don't know, 4 sessions at about 3 hours each. So half a day. If people are doing this for longer than I'm doing it, you can get a game up, the foundations of a game up and running within a day. So yeah, Rust is okay. It's not as difficult as people think. Right. So we've got a blank slate. Let's see what we shall need then. I think we're going to need something on our C drive. I'm going to call it Game Studio for now. That's going to put it with the GitHub files. That's fine. Alright. So the choices I make now are going to last a long, long time. That's the first thing to consider. This is not a project that we're going to finish in 4 sessions. Trust me on that one. So we're just going to call it Game Studio. Alright, so that's highlighted. Lovely. Open a folder. And yeah, let's put it there. So yeah, we'll have that folder. We'll select it. We'll trust the author. I don't know who that was. Was that me? Right, so we've got a game studio. It's completely blank. We've got nothing. So we need to fill that up a little bit, don't we? So let's make a project. So it's cargo, new, game studio, I suppose. Game underscore studio. Not trying to make anything named at this point because I want it generic to start off with, as generic as possible. You'll see why. You'll see why. And it's done. So, what are the rules? Well, yeah, what are the rules? I don't think we need to be outside of Game Studio. Alright, so we'll close this folder. There we go. We don't need that, so open recent can go away, clear that. Now we can open the actual folder that we're after. I'm doing it the long way round, which is this one. And here we have our files. Nothing unusual there, I hope. Did I have a reference marker? It doesn't matter. Took it a while. Huh. Alright. Now, we're not really going to be programming the source code of Game Studio. What we want to do is make a library that we can transport around and use in any project as reusable code, which is what libraries are. If you've been programming more than a month, you've come across libraries. In Rust we call them crates, and you get them from crates.io. Well, we're going to make our own. We dabbled with it in the last stream. We put a collision detector in a library. Just mainly for me to see how it worked. But if I create a library here, I don't know what the heck we're going to call it yet. Couldn't call it game library, could we? Ew, that might be dodgy. Studio library, that puts it at the bottom. Game library puts it at the top. I'm looking at the naming and where it's going to put it on the Explorer, because this goes in name order, doesn't it? So that's going to... I think Studio Library. We'll put it at the bottom. Okay. Problem. If I just put in cargo new library, it's going to create another Git. So, Rust language. First question. How to set up a new library with no Git. So it says here, to start a new package with cargo, use cargo new. Yeah, we know that. We're passing bin because we're making a binary program. If we're making a library, we pass -lib or -lib. This also initializes a new Git repository by default. If you don't want it to do that, pass -vcs none. Oh? Alright, let's try it. So it's cargo, new. We need a name for it, don't we? So studio lib. I'll use an underscore. Then we need minus lib to make it a library. Minus VCS none. Wow. That's the command. I'll take a copy of that. Just thinking, but I'll just pop that away for a second. In here will do. Alright. That's the command I'm using. I'm putting it there for a reason. I'm going to put notes down for all of this. Okay. Creating library studio lib package. See more cargo. Yeah, okay. There is. We have a library. We have a bit of success. Notes. We're going to need notes for this. I have got myself some reference material somewhere. Well, we'll make our own. We'll do our own. I want to do the full thing from scratch, so we'll plus a file. We'll call it README. And it's going to be a markdown file for Git, not to ignore. Hash Game Studio. We'll have a setup. And I'm just going to pop. Yeah. So we used cargo, new Game Studio, didn't we? Then change directory. So I can just do that. Change into the Game Studio directory. So you'll notice there's a cargo toml in there, but there isn't a git ignore, so I know there's no git. There's no lock either. Yeah, that looks good actually. And then we can use whatever we just did there in main, which was that. So to provide a single Git instance for the whole project, So now if I put this up onto GitHub for you later on when we get enough code, you can just download it as a single thing. So, I think that's a better way of approaching this. We're going to need a references area, aren't we? I'm not sure whether I want to put the references in here or in the code. We'll see. We'll see. We haven't got any yet. So that README file is the thing that gets displayed on GitHub underneath the code as like a big text box. Basically just notes on what I've done, how I've messed up and things like that. Yeah, that'll all go in here. That's nearly a basic setup. So, what are our goals? Or I call them ideas, not goals. So, I'm going to call it ideas. Sorry. So, the idea is to, well, the goal is to create create a library that can be used to make games easily. Now, for this, I'm going to use a rule. I'm going to have a single rule. Yeah, all code is from scratch. How about that? That's a biggie. I.e., no crates. Although we will need to use operating system libs for access to Windows at the moment. I'm to Windows, etc. Okay. So just as long as you know, I'm not going to be breaking any rules if I access the operating system. The only way we can do that is by an API provided by the kernel. In this case, it's Windows 11, and that API is Windows 32 API. Oh boy, are we going to have fun with that? Yeah. So that's the only thing we are allowed to use. I don't think we would need to use anything else. I love the Windows 32 API. I don't understand it all. I don't think Microsoft understands it all. So, yeah, we'll get there when we get there. Now, I don't know what this is going to look like when we're finished. Well, when we're started, actually. I've got no initial plan to say, hey, we're going to do it this way. This is the best way I can think of doing it. I don't see one. I don't see that in my mind. And anybody who makes a game engine, I think they're lying if they say this is the way it's done. Because they've got no idea. What it ends up as is usually something completely different to what you start out as. So, next rule. No development to be done directly into this project. Okay. Why? Because what we might develop might not fit, but what we develop may be damn useful. And this is another mistake I see. If somebody's doing something like a game engine, they'll start doing something and they'll say, oh no, that's not going to work, and then they'll bin it all. I've done that myself, where I've just gone here and under commit, you can see discard all changes, and you just click that button, it's all gone, and that's an hour's worth of coding or programming gone. I don't want that. Any ideas that I have, I know they're valid. Now, 95% of those ideas aren't usually good ideas, and it takes me a while to get good ideas. It can take me a week to get one good idea. So I don't want to be messing around in this project, typing a load of rubbish. So that kind of rule is a good rule, I think. And I'll show you what I mean. So you've developed something in a different project. Well, we have. Let me just close this before I do this. Close folder, yeah. I don't think I need to close that. We can just pop it down a minute. So hold on a minute, didn't we just do a sandbox? Yeah, we did. Called Midnight. In Midnight we had Dusk Till Dawn. So if we look in Dawn, we have an application. A main, an application, and an application info. Under application we did ECS input, an API, more ECS input rendering, a window API. Oh, well, this is going to change. But these files here, well, there's a copy button. So if we copy those, StudioLib source into our source folder, paste, replace, nice. Hold on a minute, that means we can have resources in here. We can have data in here. Okay, I think that's where we're going to be placing, well, those two folders, definitely. So we can have resources and data in here. Ah, there's a problem now, isn't there? Because that Dusk Till Dawn thing, that used SFML. That's only done Game Studio. Okay. Is that right? Ah, it is good. So if we go into main now, it's going to go, yikes, what are you doing? No, it's working fine. Absolutely fine. things don't exist, and it's just saying, hey, we're happy. Public constants, yeah, that's fine. Ah, here we go. We've got some red markers now. I think we can get rid of that now. Yeah, those don't exist. All of these use cases, no, they don't exist. Oh, application info does. So we've got that done. Let's save that out. But we've got all of this code and it's saying, hey, I'm happy with it all. No, it's not. Don't be silly. And I've got no idea why it's happy with it all. So let's have a look at this properly, shall we? First of all, in main, we don't have that. And I know we don't, so I'm going to take it out straight away. We don't have that. Alright, there, we've got a good start already. Application info, does that need to be here? Yes, it does. Will we have an application new? Yes, we will. Will we have an application run? Yes, we will. Will we have a print line? Yes, we will. So everything else there's okay. We just need to fix that one. Ah, now they go red. That's interesting. So we don't have SFML. Bye-bye. These constants don't matter. That one does. That's using SFML. Get rid of that. This data isn't going to be relevant. I doubt it's going to be relevant. We'll get rid of that. Move direction. That's going to be a while before we ever get to that kind of thing. Probably about a month down the line. Now I'm only going to be adding to this project on stream. So we'll be getting like 6 hours constructing it per week. I'm going to take everything out actually, for now. Yeah, I think that's the safest way of doing it. So it can't complain at me. Okay. Self window close still works. I doubt it. So yeah, you can see now that it's lying to us. So we're not using you at the moment. So we'll just pop you out. This structure we do need. Let's just get rid of the stuff that's inside it though, because that's not going to exist. That's a print line, we can do that. Create a window. No. We haven't got anything like a window at the moment. But you can see what happens now. You've created some code. But now you've got a load of notes on how you created the code. And the kind of things that you placed in there. Print application is running. Yeah, that's fine. We haven't got a clock. We're going to talk about that in a minute. While it's running. Okay. I'm just going to hit return on that. Just to get it out of the way. So we haven't got a while loop. I do want the bracket. As a reminder. Delta time, yeah, we're getting to that. ECS, we're getting to that as well. Ah, good, it went red. There we go. Still got something wrong here. I messed up a bracket. Where? How did I mess up a bracket? Ah, it's here. No, it's here. It's going down. Why is it going down there? Implementation of the app isn't right. Yeah, we've got a bracket missing. Somewhere I've commented out a bracket. That's a bit weird. How did I manage to do that, do you think? So those brackets match. This one is matching with that one. Let's test that out. Implementation of app, yeah. Windows, self-close, yeah. Okay, that's fine. It was me messing around with brackets up here, probably. I can't see it, but never mind. Make sure they all... I don't like the way that does that. Oh, it's because I put the comments here. Alright, okay, that's stupid. Right, there you go. There's your application. Finished. So, we've done that. We got rid of all of that. We've got loads and loads of text, of notes and things that we can follow. And I'm pretty happy with that. That welcome can be done. So we're going to be using StudioLib, which is spelt wrong. Let's see what happens if we make a mistake. Oh. Doesn't that make this wrong? Yeah, it does. So it doesn't automatically update it. Okay. Fine. So if you make a mess of that, you're in trouble. Okay, let's try that now. Make sure everything's okay here. Do I need to redo this? File not found. Okay. Reload the workspace. Yeah, done. Just in case. Will it find it now? No, it won't. Why not? Because we haven't told it where it is. You're done. You're done. Just a bunch. Everything's just a bunch of notes now. So our main doesn't know where our StudioLib is. We're not consuming it. So here in the cargo toml, we can add a dependency, can't we? How are we going to do that? So, well, luckily we've done it before. I don't remember these things because once I've done something once, I don't usually bother to remember it. I've got enough to remember, thanks. So we did this under the sandbox, didn't we? So we used Dusk Library in the Dawn project. So here we have a cargo TOML. Just open that up, and as you can see, we put in something like dusk equals path. So we put that in. Alright, we can change that then, can't we? We can put in studio, library, or lib in this case, and the path isn't going to be ... We're not going that far out. It's in the same directory now. That's nice. And that's just going to be a studio lib. Okay, so this is a dependency. Okay. So we add dependency. To our game studio. It's a TOML file, isn't it? Cargo TOML. It's small. I've got to get the lettering right. Oh, these uppercases and lowercases do get me at times. Cargo TOML. So there we go. Alright, so that's part of the setup. In case people want to set this kind of thing up from scratch themselves, this is how you do it. I don't do the README files in here, do I? No. I'm not that fussy. I don't know if people want to use these README markdown files or not, so I don't usually mention them, even though you're actually reading it at the time. Should we? I'll think on that one. So our cargo TOML now tells our game studio, hey, look, there's a studio lib. We can use it. That's you done. That's an old habit that dies hard. I always leave an empty line. Okay, we're alright there. This is looking okay now. So hopefully now we can say use. There it is, studio lib. We'll just put an asterisk for now. It's not being used. Okay. We don't really want to use this stuff too much, but I don't throw code away as a general rule until I need to. So we'll just keep that. And we'll do a public function. What we're going to call it? Welcome. Yeah, that'll do. It's not going to take anything in. And we're just going to do a print line, isn't it? Yeah. Forgot what I was doing then. Oh no, that didn't work. Print line. I usually put \n in here and a space. So welcome to the studio. And I'll stick an extra thingy on it because we can. And that's all I'm going to do. It's not being used. Use what? No, we're not doing that. Alright, so we've finished our library. Isn't that a fantastic library? Which means we can now do this. So it's going to be Studio Lib, colon, welcome. There we go. Oldham. But this is... What? We don't need Studio Lib, do we? I need to use that. No. Actually, I prefer it that way. So we don't actually even need that. Fine. Excellent. Make sure everything's formatted properly. Format that one. And we're done. Format document. Okay, everything looks good. In there. In there. Main looks good. Format the document. There's no format document on this. I can do what the hell I like with it. So you're done. You're done. Oh, we've run out of files to mess around with. But now you can see how I can just drag and drop files into our source folder or into our library folder and then integrate those files into the game studio. And that's why I was saying, actually that's the only thing I want to keep up. That's why I was saying I don't want to do my development here. I'll do my development in other places, in development, how can you put it, sandboxes, development projects, whatever, and then I'll just drag and drop finished files into here and integrate those. We will need to write our source file, our main file here, to use the files that we drop into the lib, but we've got a good idea on what we're after. We've already got massive notes of what we're after, and we'll be using those as a guideline on how we want to develop whatever we're doing. I think that's a good setup. Let's check it out. Let's make sure it is a good setup. Where's my console gone? Thank you. Strange. Alrighty. So I'll just ask Clippy to check our work. And it says everything's okay. We'll run. There you go. Welcome to the studio. A new application is being created. Application is running. The application has shut down. That is the expected output. That's your welcome, you know, your hello world running this application as it stands right now. It's an empty application. It doesn't do anything. There's not much of a library to use, but our library is working. Welcome to the studio. It's there, so we know it's working. Everything is set up correctly. We have one Git. So if you want if somebody says, like in comments or in chat on here on Twitch, can I have a copy of the code, I can throw it up on GitHub and they can have a copy of the code. And they can do what the hell they like with it. So we need to license it, don't we? Really? I don't like putting a license on it. So we'll do it slightly differently. This code can be freely can be used however you wish. No license. I think that's fair enough. I'm not here to make money. I'm here to have fun. So I have fun coding, so that's what I'm going to do. I'm going to have fun coding this. Right, so that's finished. We've now got everything we need. I'm happy with that. So all I'm going to do is put base setup. If I tinker around with the notes or anything, I'll just do an extra commit or whatever, but I doubt it. I probably will only do one commit per development stage. I've got a feeling on this one. Might be a good idea. But there we go, that's all the files set up, all the notes included. So that saved me like an hour's worth of work. Let's do that. Commit it all, and we're done. So, we have a game studio. Let's open a folder. And I'm going to use Rust project, I think. Yeah. Window RS, what are you doing here? Why are you here? Okay. Alright, that was the Dusk Till Dawn stuff. So that was using SFML specs derive, EGUI. We never even got to EGUI, thank God. Let's try a full game studio. I'm just going to put that for now. Right, so what do we want to develop first? And this is where I'm going to be doing my development. I'm going to be doing it in Rust projects. So anything that I develop will go in here. Once I'm happy that the files are complete to, I'm not going to say production level, but to a usable level of code, then I'll transfer them into the main project. If we find out that things aren't quite the way things seem, we'll bounce it back to here. So we're going to develop what we're going to develop first. Right. If you remember at the end of our last session, I was messing around with SFML and looking at putting up delta time on the screen as a debug printout, just to show how things could be done or added to. But it also raised a little bit of a question, because when I did it, I took away the frame rate limiter from SFML and then ran it to show, hey, look, this is taking like microseconds to complete one revolution and not milliseconds. So it was doing things a lot faster than it was displaying, because we said no, we wanted it in we wanted like 60 frames per second. And when you take the limiter off, the frequency, the update limiter off, it starts going through your main loop, main game loop, at a bajillion miles per hour. And I knew that things were happening because my graphics card started warming up. It increased by 10 degrees C, quite happily over the little experiment that we did for about 5 seconds. Yeah. If we allow that kind of thing to happen and any of our projects go out of control, you can do damage to your machine. You might not know that, but you'll shorten the lifespan of your machine if you program things badly. How did we control it? Well, we used delta time. So what is the first thing that you should do to your game studio? You should regulate time. So you don't damage anything that you do. You don't damage your hardware. I mean, in the past, I used to use old machines online. I put Linux on an old machine. I program on that, and I didn't care, and I just ignored time. But that's not quite the case. This is my main machine. So, yeah. I do care, because it's got a good graphics card on it, and I don't really want to be running it at 90 degrees C plus, just to prove a point in a programming language. So I'm going to be wanting to limit time. So the first part, or the first project I'm going to start here is time. I think that makes sense, doesn't it? So let's do that. We're actually starting to develop. Wow, cargo new. This is a dev area, so we can do anything we like in it. We can mess it up as much as we want, as long as at the end of the day we can produce some good code. That's what this part's about. It also means that if I want to change something in the studio, I don't go to the studio to change it. I can put it into, I can come back to this development and actually I was going to start listing them. That might be a good idea. Alright, time dev it is. So we've got time dev. I think I'm alright with that. It's gone green. Can I do from here? I can. I always put a readme in. It also keeps a separate Git. So if this code, somebody says, oh, I'm really interested in how you did time, for your studio, I can pop this on GitHub and say, grab a copy. Play with it how you want. This is the development of it. Transfer it into your own project. Do what you want with it. Or you could just take it from the studio and transfer the files, because they'll probably be better organised than this one will. Don't really want anything in README right now. Anything else I need in here? No. That's fine. Yeah, I'm alright with that. So it's a project, it's time. Lovely. That's looking alright. We don't need to add anything, do we? The only one I'm going to put in here currently is the standard library. So that's, yeah. Standard library we can use, well, we really should be using. Alright, I think that'll do. That's the only page we're using. Right, so I'm going to keep that open. We've got main RS. And for the setup of main RS, all we're going to do is we're going to add a module. And we're going to call it time. I think that's fair enough. Create module at time RS. There we go. Time RS. Done. Nothing else we need, is there? How are we going to use it? So let's pop that in. The first thing you have to decide on is your goals. Always decide on your goals. Always. To create a module of time functions, use to be used in any other project. I think that's pretty obvious. But never forget to put it in, because 6 months down the line, if I come back to it, I'll have forgotten. You'll find I leave notes everywhere. Right, so we've got some goals. Always change this, so I'll do my standard. Welcome to the time dev. This never gets transferred. What gets transferred is time RS. So whatever we put in here doesn't actually affect any other program. So that's just our welcome message. What else do we need for this? For a base setup? We can look wherever we like, can't we? We can take a reference from anywhere. I think I'm going to go back to the sandbox again. We used delta time in the application, didn't we? So, what kind of things are we after? How do we want to describe this? I think we'll have to put stuff in here. Functions for creating a clock, for measuring delta time. By now, I hope you know what I mean by delta time. So if we have a look at how our application from last week did it, we had this thing here. So we'll copy that. Then we went to run the application. Okay. So we had that kind of thing. Then we came up with this kind of thing. We had a dropping of frames here, which has got nothing to do with a function. That's an if statement, so we don't copy that. That's a logical statement, which is up to the application, not us. Okay. So that's all we got, really, to go on at this point in time. Literally. So we can get rid of this. Excellent. Why'd you put it back here? And that's really what we're looking at. We're looking at 3 commands that we used, and we just need the functionality for that. How do we want to do it? Well, we've got this thing called time. We've got this thing called clock, both of which I recognize as objects. Some people say they're types. I We'll call them objects. So we've got two objects there. Which ones do we need? To be honest, is this needed? We'll come back to that. That's a discussion within itself. We might be ignoring that line. And just make ourselves a clock. Because really, it's only the clock we're using. Standard crate. Modules. Time. It uses duration. Instant now. Using instant to calculate how long a function took to run. Instant now, instant elapsed. You might be thinking, but hold on a minute, if you can do that, you've got delta time. Not really, because a while loop has a closing brace on it. So I don't trust this. So ownership could be a problem. We've got duration, instant, system time, error. Oh God, we've got that, have we? We'll have to talk about that. Try from float 6, error. Oh no! But we can use floats. Unix epoch, an anchor in time which can be used to create new system time instances or learn about where in time a system time lies. Yeah. Yeah, I know why that's there. Alright, so we've got duration. Can we have a clock? Got the source code we could look at. Do we have a time structure? I'm going into this, aren't I? I shouldn't be. Right, so let's get this set up first. We'll set time up, we'll set main up. Don't need anything there. We've got a readme. Alright. Let's try Clippy. Alright, that's okay. Just run it. Welcome to the time dev. Didn't put a thing on it. It's the only thing I want to alter. Alrighty. Lovely. Everything's set up then. Okay. So we have a project for time. We will be doing something on that. When it comes to the Win32 API, am I going to break the rules? No. I think I'm going to have to sit down and sort something out. Because that's probably going to be a development project that's going to be done on and off in you know, over a span of months. Do a little bit whilst I try and understand the Windows API. Right, we've got that far. Time. Why is this so awkward? Computers can't do time. Yeah. Remember we were saying about floating points and the floating point errors? Well, we've got a similar problem with time. If you save two files out in sequence within your code to your storage medium, hard drive or SSD, whatever you've got, you can't guarantee that the second one will be saved after the first one. You're not running your program in parallel. You might be, but let's presume you're not. So you're not using anything strange like that. But the second file you ask it to save out can finish slightly ahead of the first one you asked it to save out. That's because of the way the operating system works, and it's also an indication that the second file might be smaller than the first. Also, you have to realize that time itself is not a definite value. If you want to say now, nothing in the real world happens at the same time. Doesn't matter how you try and make something happen at the same time. It can't. In physics or astrophysics or whatever, two things cannot happen simultaneously. It's an impossibility. There will be as many zeros, it'll be 0 point, as many zeros as you want, to infinity, with a little 1 at the end, saying, no, one happened before the other. That's a fact. If two things do happen in physics simultaneously, I'll be damn surprised. There might be a case for it, an edge case for it. I don't know if in the universe two things can actually happen at the same time. I'm not that good at physics. But I'd like to see the proof. Yeah. So that's also a problem. Another problem is, to measure time, you need to write a piece of code. That code takes time on your CPU to execute. So the time that you say is now is actually in the past, because the CPU is then asking for that time. So your code is running, and it will always give you a past now. So we have to bear that in mind. Time is this awful, awful, awful thing to deal with. And lots of people fail at dealing with it very well. What you have to do is ignore all of that and just say, it doesn't matter. Why doesn't it matter? Because you're going to be running the same code every time. So any discrepancies that occur should occur equally. But because of the way modern operating systems work and the way modern CPUs work, that's not true either. Yeah. So even your discrepancies are out. And this gives rise to errors within applications and all applications at some stage should be using time. It's the basic concept that makes an application tick. And they call it ticks. They say that, okay, you've got this many ticks to complete this operation. Get to it, computer. Here's the instructions. We'll wait for you at the end. And that's how you do parallelism. Yeah, as soon as you go into that area, you've got a can of worms to open. This module time. Module time, examples. Structs, constants. Okay. Right, I think we're going to be duration type to represent a span of time typically used for system timeouts. Right, an instant measurement of non-decreasing clock, yet non-decreasing, note, because you can measure 2 instances of time and get a decreasing clock by accident. Opaque and useful only with duration. So duration seems to be the main thing. Okay. System time errors and stuff like that I don't give a dingoes about. We'll let the operating system deal with that. We'll go for duration. Here we go. Including add, sub and other op traits, implements default by returning a 0 length duration. Yeah, we've got a 0 length duration. We've got a 0. Huh. It's got a constant. Max, milliseconds. Sorry, microseconds, milliseconds, nanoseconds, second, and 0. Okay. So we've got the constants. It's all in the standard library. That's helpful. We'd have to do those ourselves. So we can have duration. Formatting duration values, yeah. Struct duration, private fields, you're not going to tell us. Thanks. Formatting duration. What are you measuring, by the way? Whole number of seconds. Right. Each duration is composed of a whole number of seconds and a fractional part represented in nanoseconds. So you're actually measuring this in 2 numbers. That's nice. If the underlying system does not support nanosecond level precision, APIs binding a system timeout will typically round up the number of nanoseconds. Okay. Yeah, we've got a problem there. You might not know this if you haven't done computer science or operating system science or God knows what kind of science. Linux and Windows measure time differently. Yeah. Linux will go down to the individual nanosecond. Windows will go down to 100 nanoseconds accuracy. So the accuracy on your code, if you're doing cross-platform, is different. Did I say there's problems with time? So, yeah, duration, millisecond, yeah, okay. Const second, okay. Oh, it's an implementation, right. Second, millisecond, microsecond, and nanosecond, which is 100, is it 100 million? That says 0. Unstable feature. Oh my god. So they're having problems with it as well. Okay, I'm not looking at that then. Fine. $1,000 million. So there's 1,000 million nanoseconds to 1 second. Okay. It's nice to know. We can have a new duration. I think we need to use instant. Yeah. I'm not sure duration is going to help me on this one too much. Let's have a look at instant then. Instants are always guaranteed barring platform bugs. To be no less than any previously measured instant when created, and are often useful for tasks such as measuring benchmarks or timing how long an operation takes. We want to time we want delta time. So this is timing how long one frame takes to render, or how long one tick of your program takes to complete its calculations or whatever. So this sounds a bit better. We do have a thread for sleeping, so that will sleep the whole thread. We have to call that in the thread that we want it to happen if we're doing multi-threading. Okay. Operating systems, Windows, query performance, yeah, that's normal. See, Unix is monotonic clocks, so they're all the same. Yeah, it goes into a bit more about operating system APIs here. We're not going to be dealing with that. We're going to be using the standard. So we're going to use that. Let now equal instant now. Oh, cool. We've got something. We've got something. And I think I'm going to make a clock. I'm going to make a clock object. I don't think I want a time object at this point. The standard library seems to be covering most things, and it will throw errors if everything goes foobar. Okay, so we're going to need a public struct. We're going to call it clock. They put a capital C on it. Am I allowed to? Yeah, of course we are. Clock. What this is going to have is an instant. So this is going to be a start time. Don't know what the start time is going to be. We haven't got that far yet. It just says it's in STD time. I think it's a duration. Possibly. We don't know. Alright, let's do that then, because we don't know what that's going to be. We'll just implement it. New. And that's going to return a self. Okay, let's find out what start time would actually be. So let now equal, and it's instant Now, what does that give us? An error. Oh, right, yeah, of course. So we would need a clock. I don't know. We'll do that for a minute. Clock. We need a start time. Now, something along these lines. Let's clean this up so that it actually works. That might help. I've done something wrong here. Yeah, that's not wrong. Public function new. Implement app. Right, got it. So implement its clock. Let's get this right, shall we? So public function new. Okay, we're cleaning up. It's instant. Okay, that's interesting. Never used. Yeah, I know it isn't. That's fine. Alright, so we've got a clock. With start time now in it. So we can now make a clock. Is that printable? It is, but it'll just be a 0, won't it? That should be a 0. Do we need to know it? I don't think we do. I think we need to keep hold of it because otherwise it's going to die, isn't it? All right. We need to test this out. We need to see what it's actually doing. And that's why I'm in a development area. So that I can mess around and see if we can find out exactly what these things are doing. Start. And restart. Expect the error. Yeah. We can do it with start instead of new. It's not going to take anything in. Alright, we'll do that then. Expecting an error. This can throw an error, can it? It's a structure. This isn't throwing an error. Oh, now plus duration does. Well, we've got a query on it. All right. That's an interesting thing. Okay. I'm not sure whether we're going to be getting errors on this or not. Hopefully not. Hopefully it's safe code. Yeah, we'll go with that for now. How can we test it? That's what a development area is all about. So let's make a clock and start it. That's the code. So here we're going to create a clock. So that creates a new clock and starts it. As of that, it's got a now. Yeah. Alright, we can clean this up. That's not a problem. Failed to resolve, quick fix, import time clock. Why did you put me at the top? What am I doing? It's easy, it's just you do, is it Alt? Control? Alt? Alt. I'm learning the keyboard commands. Okay, we can pop you there, we can pop you here. Time. Yeah, I'm gonna leave it at that. I'll leave it at that for now. Okay. So we need to be able to measure do something. It takes time. So we need to do something that's going to take us some time. We need to then measure how long something took. Show results. Okay, I think we've got a program. Yeah, I do write my programs in English. Sorry about that. Old habit. So let's do something that takes some time. For an iterator. In 0 to equals, no, don't need equals. I've noticed that they're using this underscore thing. I like that idea. So they're using the underscore every 3, aren't they? I like that idea because it makes it clearer what the number is. You don't need to put it in. It just makes it more readable, I guess. What are we going to do? We'll put let count equals 0. So we're just going to do count. It's plus equals 1, isn't it? Yeah, that'll do. I was just going to put plus plus there, and we're not in C. Okay, that's looking all right. Ah, I didn't know we didn't need to do that, but anyway. Okay, we got rid of that. Okay, measure how long something took. This is going to be an interesting one, because what we did in SFML was a clock restart. So let's do that. We'll do a public function. How was it done though? Clock dot restart. Okay, so it goes in here under the implementation. Public function restart. It doesn't take in any values as seconds. That's going to be interesting. We'll come to that. What are we returning? We're returning something. I'm not really sure what. So let now equal instant. Yeah, we need a self. So it's and mute self. Okay. Let, I don't know what this is going to produce at this point. So I'm going to let what we're going to call it. Need to call it something sensible. Elapsed time equals now minus then, which is self. So we did need the start time. I don't know if that's the way to do it. In my own mind, yeah, it is. But look what we're getting back. Look at the notes it's putting in here. Instant as sub. And arithmetic. For standard time, : system time, implements subduration, which permits operations. System time minus a duration. Okay. What are you actually giving back, though? a point t. Really? I'm gonna try a dot unwrap on that. We can't. Alright. How do we use that elapsed time? You can see that how it's all very weirdly done. So so let our time equal elapsed time, maybe, dot we can do that lot, but I don't actually know what it is. Try into type ID. Try into? I don't know. As soon as you start doing maths with time, you're really getting yourself goosed. This is the wrong way of doing it, isn't it? I think we can just do self dot, no we can't, self dot start time dot duration since elapsed. That gives us a duration. That makes more sense. Okay, we'll have a duration then. Do I need to do anything with that? We could really do with that being in seconds, couldn't we? No, duration. I don't want to return a duration, do I? I don't want that. I want an F32. And you're going to give me an F64. Thanks. 32, please. And it is that I wish to calculate and return. You can see the struggle now. What I don't want is something quite strange. if duration is split into two parts. It's split into the seconds and also the nanoseconds as two different values. It's a structure. Seconds and nanos. I don't want that. I don't want to return that to the main program. So we have to convert it into something that we can use. Alright. So time, we want an F32 here, equals the elapsed time as secs F32. There. Will that work? Cannot mutate in... sorry. Alright, let's get rid of that line. I'm not using it. Okay. Value assigned to time equals that. Never used. Okay. Variable does not need to be mutable. Okay. We're going to send that back, but what are you? You're an F32. What are you? Duration. As secs. Returns the number of seconds contained by the duration as F32. That's wrong. Oh, the return value includes the fractional nanoseconds part of the duration. So it does include everything. Are you sure about this? Alright, it does give us an example there that says yes, that is the case. Alright. Okay, it seems to be converting it in the whole of the duration into an F32. Right, and we're returning that, so we've got to restart. So at this point, we need to take self and restart it. So that will be start time. Do we need start time? Yes, we do. Thought we did. Start time, and that will then equal an instant of now. That restarts our clock, if we're allowed to. Yeah? It's not complaining. We made mute, yeah. Do we need that mute? No, doesn't seem so. Alright, I think I'm nearly okay with that. We don't need that. Okay. Just taking excess garbage out. So we get the elapsed time, we turn it into a floating point 32 byte, and we then restart the timer by just putting it back to now. and then we return the value that we've calculated back to main. Okay, measure how long something took. So let's delta time equal clock restart. We're not putting in as seconds, are we? Okay. Delta time now equals our clock restart yeah, okay, and we can show the results theoretically. So to do that, we're just going to print a line, and the line is going to be that's going to be count. Counted. We took, and we should just be able to put delta time in here. I'm hoping. All right. What do we think? Just for an example, we're only counting to 1,000,000, so it shouldn't be a second. Maybe we need to increase that. Why do I keep getting this one here? Explorer, one unsaved file. Okay. Is that what that means? Thanks. Alright. Cargo Clippy says everything's okay. Let's try running it. It worked. Okay, bio break. Let me just clean that up. Just clean the output up. Yeah, it worked. Be right back. That's an interesting number it's just pumped out. 5 milliseconds. Five microseconds. No, 5. That doesn't seem right. But anyway. What does milliseconds do? Oh, we're in standard again, are we? What was that? Saw something at the bottom. Da 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 da. What can we do with this? What are we allowed to do with this? I did see something in here that might become useful. Because I don't want that kind of format. It could be handy though. Hold on a minute. That kind of format output would probably be damned useful. It's an F32, isn't it? That's usable. As a delta time, that is usable. We need to some kind of update, don't we? Right, so we need to change that into 1/60th of a second. How are we going to do it? 1/60th of a second will be 0.016666. I'm guessing. Maybe we need to have a look at that. See if my maths is okay. I think that's the answer. So if we want to make our frame tick 1/60th of a second, we have to alter the outcome. That puts an extra command in. Now I know that command is in SFML, so they hid it. Where did they hide it? I bet you anything they hid it behind the display update. Swapping buffers. What's the betting? Because that's where it would normally be used. I mean, it's helpful that they do it. It's, you know, have this frequency kind of thing. So we're going to need to have, with our clock, a frequency. That was hidden within the window. Found it. It's the window update thingy. Yeah. Let's open our last project and have a look at that a bit better. So in our application, I don't think I'm bothered about that. Window, here we go. Set frame rate limit, max FPS. Because we need that to avoid graphical issues such as tearing. But they're setting it in the window. But what happens if we want to make an application that doesn't have a window and just runs on the command line? We still want to set a frame rate limit. Do we need it as a separate thing? There's the concept. I don't think I want it on the window. I think I want it on the clock. But that then becomes complex. We know from this it has to be an F32. We can put it in here. Let's pop it down as a note. What did they use? I'm using SFML as a guide because that's what we've been using. A U32. Oh god, I don't really want that. But it does make more sense. So I'll break the rules a little. I'll go for ease of use for now. So frame. Yeah, we'll just call it frame rate. It's going to be an F32 for us at the moment because, yeah. We'll pop it in here. Hello? Can you get this off the screen? I don't know. Frame rate. Can you get... Thank you. 0.0. No. We'll set it to a reasonable frame rate. But we will allow the user to change it because that's fair. If you pick this code up from me, you might have a monitor that runs at 120 or 140 frames per second. So you might want to set the frame rate to something different. Yeah, so I think we're going to do that. So we'll pop that in. And we may as well put it on the clock. So there's set frame rate limit. That's going to take in and mute self. And it's also going to take in a frame rate. Or a rate. We'll call it rate. And it's just going to be an F32. Is it going to reply? No. All we're really going to do here is do a self dot I can see problems with this, so I'm hesitating. And that just equals rate. Yeah, we'll do that. Just wondering if we should start it at 0 for people who want to break the graphics cards. Yeah, we will. We'll give that option. I think 0's a better default than 60. There's too many different types of displays these days. So if we go back to main, once we have a clock, yeah, we can now do clock, set that frame rate to 60.0. No, that's bad. Yeah, I know now. I've just understood why it's a U32. So we'll follow on. I've just understood it. So now we can do a clock update. What are we going to call it? Check frequency. Set frame rate limit. Limit frame rate. Maybe. I don't know what to call that. What we call it matters. Check. So something like check frame rate. What makes sense in English? Enforce? It should start... no, it doesn't matter. It should start with frame rate. Really? Enforce? I know what this means. We're 2 hours in and I need a cup of coffee. That's what that means if I'm stuck on a word. Let me just go and put the kettle on. It looks silly. I'm going to keep it for now. Right, how do we enforce the frame rate? Yeah. Kettle's on. Well, we're not going to find it in module time. Right, so we were able to get this number here. So it's exactly the same kind of thing, isn't it? I believe we'll just pop that in there for now. That gives us the time. Don't need a mute self. We just need self. Alright. Can we put that on here? can. Gives us an F32. Alright. So that does everything. Okay. Does that give us the same result? I hope so. Yeah, it does. 59077. We got 56, 56, 59, 59, 62, 59. Seems to take longer. Huh. Let me just think about that 1 second whilst I make me coffee. Why did that take longer? Well, I know the answer. There you go. Make a cup of coffee and it gives you the answer. Wow. Cups of coffee are underestimated. Why did it take longer? Simple answer is, when we compiled it or recompiled it, the code that it generates is different. Why is it different? Because we are now missing on the stack, the program memory, a variable or a reference point on the stack where it can store the elapsed time, the duration. So it's having to create a temporary, destroy it at the semicolon, instead of just doing a cleanup there on the closed brace, which is normal. Because Rust works that way. It's got a borrow checker. So the borrow checker alters the way the code works in the background. Because we never create that variable. So it has to drop it at the end of the command. That's the only reason I can think of that it could take longer, because it's got an extra cleanup step to do. Noted for testing in future, whether that is correct or not. But it's an interesting observation we've just made about the way Rust works, I think. This is going to get a little bit complicated. So we can use that now. This is why people might want to calculate how long a function took to run, as it says here. Because the way you write your function actually affects the length of time it takes to run. So, or affects the amount of time something may take overall. And it's not happening in our function here. The clock difference is happening here. So, like I said, running code can affect the result. And I think it is doing, but it might just be that my computer's warmed up and it's running slower, or the computer went to sleep or something, because I'm not running enough. So it could be entirely due to the operating system. Yeah, there's that. Right, so we've got an elapsed time. How do we enforce our frame rate? Well, we have to take our frame rate, which is 60. We're going to be doing a calculation. That's no bloody good. Alright, we'll do the calculations. That is an F32. Alright, we are going to hold it as an F32, otherwise it's just going to mess everything up. I'm still taking inner U32. So now this is completely rubbish. So that needs to be as float. Does that work? Why do you want a C float? Not sure how this is going to be working, but the frame rate is going to be 1 over that. That's giving us what? To the type of the binding, yeah. Found at U32. Is this one of those weirdo thingies? That you can do. From bits. No, it doesn't seem to be one of those things. Casting. Haven't learned how to cast properly in this. I'm going to put brackets on it and see if I can dot her. Two owned. Oh. Go up to a string. Bytes. How do I convert a U32 into a float? Cast. Not something I've ever really needed to do before.